Ladies and gentlemen, Weekend Modder here. I'm going to be doing a video today of the modding process on an Xbox 360 Slim. This is actually a Modern Warfare 3 edition. What we can tell immediately, so obviously I've taken the case off the console, I've removed the DVD drive. Those things are really straightforward. There's tons of YouTube videos out there for how to do that, so I'm not bothering to cover that part. So I'm jumping straight in with the process of actually modifying the console. What we can tell by the two vertical orientations of the pin headers here, J2C1 and J2C3, is that based on this positioning, what we have here is a Trinity motherboard. And then we can further tell down here by this little area that it doesn't have a module on top of it, that it does not have the 4 gigs of built-in memory. Not that that would really affect what we do right now, but it's worth noting. So the only other thing I'm going to mention here is that the little connector for this sound thing, basically this is the speaker that makes the startup sounds, so the special edition noise. Just be real careful with this plug. If you need to, what I use is this little metal spudger to just insert the end in there and then kind of push that out, because if you just yank on these wires, you have a tendency to either disconnect the wires from the plastic housing or actually disconnect this entire thing altogether. So step one in this RGH process that we're going to cover here is going to be to use a fiberglass scratch pin to take the top layer of coating off over the NAND headers. So this is the header, actually the official name for this header is a JTAG header. We're not actually going to perform the JTAG modification to the Slim because the Slims cannot be what's referred to as the old school JTAG hack. They have to be RGH or reset glitch tagged. But this header is still technically called the JTAG header. It's just an input-output standard. Your phone has a JTAG header on it and stuff. So take the scratch pin and we'll just come in here and run it right over these for just a few scrapes back and forth on each one. And you'll notice that after I get done, you may even be able to see this in the camera, that the points will have much more of a sheen to them, and they will be a lot more clear. You know, basically the solder will adhere to them better because the metal is actually exposed. So just take a quick Q-tip here that I've wet with a little bit of rubbing alcohol. And that cleans those right up. Then I've got some Amtech Flux. I picked this up off of either Amazon or eBay, and you can just go right here and just lay a little coating of it down over the points. Now I've got my soldering iron that I'm going to pick up. Now I use an adjustable temperature soldering iron. I run mine at about 400 degrees Celsius, so it's really hot. So you'll notice that I don't maintain contact with any of my points for too terrible long. All I did there was just run the soldering iron through the flux just to melt it down. So the NAND points that we care about for a Trinity console are these 5 on this side. So 1, 2, 3, 4 top ones, and then on the left side as it's oriented now, this one actually usually takes a bit more heat because this last one that I'm doing that I won't do the opposite side for is the ground, and because it runs into the ground plane it dissipates heat a lot more quickly, so it takes a little more heat to warm it up. So those are the ones that we're going to pre-tin here, and then on the right side header, on the J2 G3 header, we're going to do these two and these two. And then this part will vary based on which glitch chip you're using. So if you were using a chip that required 3 volt power, you would do this header as well. Since I'm going to be using the Ace V3, I'm going to do this lower one that doesn't have one beside it, and that is actually a 5 volt power point, because that's what the Ace V3 requires. Now, before anybody jumps in and jumps all over me, there is a way that you can run the Ace V3 off of 3.3 volt, 3.3, but I mean, might as well just use what it was designed for. So Now, what I'm going to do is grab my NAND read-write wires. So this is the kind that would come with either a Nandex or a JR programmer. All I've done here is just beef up the connector a little bit because I actually wore several of these out. So it's just some hot glue and some tape here. And then they're color-coded. The diagrams that you get from Team Executor and that also exist within JRunner will have these exact same color codes. So let's just get right to it. Sorry for bumping the camera there. So the first one that I always do is the black wire, and that goes into the upper right here of the first header. So you can see all I'm really doing is having to re-liquefy the solder that I've already put down, and then that allows me to just kind of shove the wire end in there. And these I've modified slightly. You can see the little piece of heat shrink there and runs to the wire. These are actually the legs off of some resistors, so they're a little bit more sturdy than just your typical wire ends would be. And that's because I've probably RGH'd 200 consoles using this particular set of wires. So black, brown, red, orange, and then finally that last one that was our odd man out, that's yellow. Yellow is actually ground in this case. And then the two up here are blue and green. Blue on the left and green on the right. And again, the diagram that provides these color codes available all over the Team Executor website, as well as within JRunner. If you click the images drop down and go to Slim or Nandex Slim, it'll give you this. So what we have done here now is soldered in the header that will allow us to read and write to the NAND. So that's kind of step number one on this process, is to solder in that. So from here, what I'm going to do is I'm going to turn the console sideways so that I can reach my power connector. Oh, dang it, I bumped the camera again, sorry. So I can reach the power connector here. So I'm going to plug in power to the console. However, I'm absolutely not turning the console on, simply just providing it power so that the chip is powered. I've got my Nandex here. This would work interchangeably either with a Nandex or a JR programmer. And I just plug that in as it needs to be connected. And then from here on the PC, I'm going to fire up JRunner. And I'll pan over to this here in just a second. So there's my children, my desktop background. So here's JRunner. Let's see if I can get you a decent view of this. So what I'm going to do first and foremost is click this little question mark symbol that's right next to the NAND type. Clicking that down here tells me flash config 00 cannot continue. So this is maybe not a terrible thing because, let me see if I can orient this thing. So sorry for the crazy camera antics. Let's see if we can make this work. I'll just move JRunner. There we go. So this flash config 00, what this tells me is that it hasn't read the NAND configuration. Based on that config, it can tell you what type of console you have, that sort of thing. So all I'm doing right now is actually just unplugging that header from the Nandex and then plugging it back in and kind of wiggling it around, because mine is a little finicky and I'm pretty confident about my soldering. So now I'm going to click that question box again, and look at that. Now we get a flash config of 23010, which it then tells me is a Trinity. So if you are super confident in your soldering and you really feel like that's all that it could be is the connector, you can try just unplugging, replugging, which is what I did. Now we'll just go ahead and initiate the read. So I'm going to come up here and hit read NAND. You can notice that I've got 2 copies set. It puts up this input name category, which all I do is click OK to that. And you can see down here that the progress is going to start, and it's reading the first copy of the NAND. So once it gets done with the first copy of the NAND, it'll go into a progress and read the second copy of the NAND. And I'm going to pause the video, and then I'll resume when it's close to being finished with the second copy. Alright, so here we are resuming right before the finish of the second NAND. So you can see here we initialized and did NAND dump 1, and then now we've got another reading NAND here, so it's completing the second. So when this gets to 3FF, here in just a second, it'll have completed the second NAND read, and from there it will compare, and then we see that NANDs are the same. Now in this particular instance we didn't have any bad blocks, so you don't see anything about bad blocks or remapping, but if there were, that would be totally normal and you could continue on exactly as I am at this point. So the other thing I'll point out here is if you click this button that says Show Working Folder, you should get a view of this, which will have your checksum, which is how it determined these two files are the same, and your NAND dump 1 and NAND dump 2. Now if you're a first timer and you've never done this before, what I would suggest at this point is that you take a copy of these and then put them like on your desktop or in a separate folder somewhere, because JRunner can read and write to this folder. If you just slap them somewhere that JRunner doesn't read and write to, you'll be guaranteed that you've got a good backup of your original retail NAND. So at this point, what I also like to do personally, and this would be optional for somebody, but I will click the CR4 checkmark to indicate we're doing glitch 2 with the CR4 speedup files, even though we're not actually going to use a genuine CR4. And I click the Create ECC, which creates that ECC file. You can see ECC created, and in that working folder you'll actually see image underscore 0000 ECC. And then I write that ECC. So that actually writes that, which is only 50 blocks, to the NAND. Now by doing this, I've made it so that the console will not boot retail. Do not expect that after you write the ECC file, the console will boot retail. It will not. The only way the console will boot now is if it's got a glitch chip wired into it, which is what we're about to do, which is why I do that now. There's no reason that you could not skip that part and do it later. So pause the video for just a second, reposition the camera, and continue on with the installation process. Alright, so what I've got here is an Ace V3. Ace V2s come packed in the same way. It's got a little wire package here at the bottom, and then you also get the chip and then in a little adhesive pad on the back. So if we go ahead and tear into that, you can see the chip and the adhesive pad. And then find my scissors here. Take a pair of scissors and just carefully trim that little edge there, and we can get our wires right out. So there's a couple of things I want to show you that'll help make this a little better. First of all, the pad that they give you is not really large enough to cover the entire back. So you can slap the thing in the middle. Personally, I position them a little bit more towards the end where these through holes are for the programming, just because I want to make sure that that part does not ground out against the motherboard. So this provides a little bit of a spacer to make sure that this part doesn't touch anything else on the rest of the console. What I also like to do is take my soldering iron and the solder and pre-tin the pads that we're going to solder to, because the rosin core flux, or the rosin flux core, kind of does a little bit of spattering when you melt it onto these pads, and I think it just ends up cleaner if the things are pre-tinned outside of the console, but this isn't really super important. Alright, and the other thing that I want to show you about these is, I'll get rid of my trash here real quick, is that the wires that they provide to you come in two different lengths. And for the Trinity install, we don't actually have to really change the lengths of these too bad. But we do want to trim the ends, at least on one side. So if you notice, if I use my finger as a background, the lead there is like really significant long. Like that's I don't know, 1/8 of an inch or something of, you know, wire that's left on the end there. So what I'll do is I'll just take a little pair of snips and go down most of the way till it's just a little tiny bit hanging off. And here you can see considerably shorter, just a tiny bit exposed versus the other end that's untrimmed, big old long thing. And that will just help keep your installation neater later, because you're going to be jamming that trimmed end into a solder ball that you've placed on the console, and by doing that it's going to melt back some of the insulation anyway because of how hot everything is. The one exception to that is one of the longer wires I don't trim because we use this for ground, and then on the other one I do trim it down, because on the ground it doesn't really matter. You want a nice long lead into there. So if we bring the console back, which I've now taken out of the motherboard cage, what I'll do is take the glitch chip itself, and then for an Ace installation on one of these, I'll peel off the backing, and the chip will be positioned right here essentially. Now what I'll point out to you when you're doing this is be careful. You're actually going to solder the D, the CPU RST, to one of these tiny little resistors right here. So you want to make sure that you're not over, blocking that resistor. So basically just position it. I like to think that I should still be able to see this through hole here, and then not quite touch this capacitor back there. So I mean, basically that right there is where I'm going to put it. And then on to the interesting part of actually wiring it up. So I just go in order for, kind of obvious ease of use reasons, whatever. I'll just remelt that ground, shove the ground wire in there. And it is so long, you want to make sure that you're not touching the little capacitor there or whatever. And then for the ground, I run it under the DVD power wire there, and then let it come out, and then bend it over and get it prepped. Now you can see where I've kind of hot glued this back on. They use a piece of really crappy adhesive, and this thing will flop all over the place, so I just put some hot glue on it. It doesn't really matter. And then I'll take a fairly sharp implement. You could use your tweezers or whatever, but my little spudger has a nice little hook on it. And I'll just scratch this up a little bit so that it has a nice rough surface for some solder to adhere to. And then take a bit of solder and melt that right on there. And it should, be pretty sticky as far as like adhering to this, because this is just grounding it out to the chassis. And then take the wire, get the solder nice and hot again. You don't want to stay on here for too long because you could potentially damage the AV port inside there if you did, but that's pretty much it. Just a solder blob there, and it grounds it out. There are other guides out there that'll tell you how you can use some of these as ground points, or even one of these. I just really don't buy it. In my experience, it hasn't worked great. Just grounding to the AV just has always been reliable for me, so that's what I do. So, next point is going to be power. And this is where starting to have the little wire trimmed off is going to work in our favor, because we're going to go... let me reposition the camera. Alright, so we're going to be going from the power point here to this bottom pin here, which we pre-tinned. So you can see that having my little short wire, what I'm going to do is just position that, get it ready, and then I'll heat up this solder ball by just placing my soldering iron on it, shove that in there, and then bam, nice clean tight solder joint with insulation all the way up to it. And then that goes right into my power, and then there we go, we've connected power to that chip. Next, we're essentially going to repeat that same process on the two, left and right solder balls there. This one on this side is going to be E. This one on this side is going to be F. And then we'll connect those to the appropriate pads on the glitch chip as well on the Ace V3. So there's F, right? Because F we said is on this side. So that one's all nice and connected. And then do the same thing for E here. We'll just heat up the solder ball, touch that little end, sticks right to it, and then go right here to E. Bammo. Now the next part will involve actually connecting the C or post, and what we'll do there is I'll take this other super long one, the other one that we did trim the end on, and I'll connect that to point C, and then I'm going to route that under these other wires and then bit through that big through hole, and then when I pick it up I can use my finger to pull that all the way through, so you can see it's nice and tight and able to just wrap around that corner. And then we'll flip this over and I'll show you where that goes. Alright, so what I've done here is just flipped over the console. You can see that same through hole here with the wire that comes out to it. Now this is part of making sure that this console is going to boot quickly, is that what we want to do is just lay this wire path out such that we make sure we cut it so that it's going to be nice and tight. So the point that we're going to be soldering to is what I like to do is count 1, 2 over, 1, 2 up, 1 over. So it's you know, this point right here that we're going to be soldering to. So I'll pull it nice and tight, get it in position with my little snippers, make sure that it's going to be able to hit, and then just bam. And then what we'll do is we'll just strip back that wire a little bit. I have a little specialty tool for doing that. Exposes a little bit of the end of the wire. Take the soldering iron and tin up the end of the wire there, and then tin up the spot, and then it should just be a matter of touching those two together at the same time. So we'll just put a little bit of an angle down on this bad boy. It's all pretty small stuff, so just take your time. And I'm trying to do this with visibility to the camera, so that's adding to my difficulty. Here we go. There we go, this is going to do it. So there we go, we've soldered to that spot. It's nice and firm, you know, connected there. We don't want to be too abusive on it because we can rip that pad off and then we're up a creek. So what I like to do there is just take a piece of electronic tape and take it and put it right here over to hold that sucker right in its nicest spot. So now if we flip the console back over, we can see that we have everything installed except for letter D here. And D is the CPU RST, and that's the one that we're going to solder to this little tiny resistor end right here. So what we do for that one is the other half of that wire that we just trimmed off, that we have the edge all nice and short on, so we have this trimmed all nice and short. We're going to position that right where it's going to go. So it's going to go there, and I'll just hold it there with the tweezers for a second. And then I pinch my fingers down to where it's at, so I know that that right here is where I'm going to need to cut. So we'll cut that, and then I'll take my little specialty tool and trim this over here. So now we have some nice wires exposed. Rotate the motherboard this way. Nice long length of it exposed here. And then I'll solder down this end first. So there's that connected. And I'll rotate it back one more time. And then we'll take the tweezers, position this, just make sure we're doing a fit check to make sure it's going to be able to reach. So it looks like that end is going to get there just perfectly. and then we'll dab it up with some flux and get it down here in just a sec. Alright, so what I'm going to do now is take my flux pin here and give me a little narrower thing here, so I'm just putting a little bit of flux there. You can see it on the end of the Q-tip, and I'm going to just dab that right here on the end of that resistor so that it is nice and fluxed up and everything will work the way it should. And what I'll do from here is take nice clean soldering iron and I'll apply a little bit of heat to the back of that and dab it with some solder. And then now when I go in with that wire, nice hot solder, everything all fluxed up, it just bam, and is nice and connected. And again, we can wiggle it a little bit just to make sure it's nice and sturdy, but you don't want to pull too hard because you can rip that resistor right off there, and if you do that, console won't even boot. So now we have successfully fully installed the glitch chip. The last thing to do is we actually want to program the chip, and the way that we do that is via this header here. This chip, the Ace, already comes pre-programmed for a Corona console, but we are actually using different timing files meant for a Trinity console. So what I'm going to use to do that is my trusty Super NAND flasher here. Generally speaking, I do not recommend these. The quality control on them is pretty crappy. I bought like 20 of them and had a bunch of returns and problems. So typically I would recommend using the Nandex or whatever, but I happen to have a little cable that I've set up here that allows me to fit the pin headers into this and just hold it without having to solder all this on there. With these, what you can see here on the Super NAND flasher is that it starts with VCC and then goes to TMS here on the labeling of this. So we have TMS, TDI, TDO, TCK, ground, and VCC. What I personally do is just always keep the TMS on the black and the VCC on the red. And in orientation for the Ace, the one with the square hole, see how that is squared off versus all these around? That is your TMS. So I know that the black wire goes to the square hole, which tells me that that one's going there. So I'll put that in here. So let me go ahead and connect this up via USB. And then when I hold this to it, the chip lights up, as you can see there, because it is getting power from the NAND flasher. And then on screen, what I'm going to do is browse and navigate. I'm going to choose the advanced drop down, the custom. Well, you know what? Give me a second. I'll reposition this to show you on screen. So what we do here in JRunner is we're going to go advanced custom NAND CR functions, and that opens this little window. Then from here, what we're going to choose is the XSVF, because we're programmed, that's a timing file type. And then you choose the little ellipsis button to select the actual file. Mine's going to take just a second to spin up here because I'm reading from a USB hard drive that likes to go to sleep, so it takes a second. So you can see here that I've got my JRunner folder, common. I saved these as 15432. That's the guy who wrote them, his timing files. I'm going to do the Ace RGH2, which are the original files that he loaded. Trinity 300 megahertz, timing 60.6, and then I like to do the 0.5 file to start with. That's my personal recommendation. You can get those files over at teamx360.co.uk. Then we'll click Run on that, and down here you can see that it programs the file and says Done. And then I usually just do it twice for good measure, just to make sure that they program. And that's it. Now we have programmed the chip. What we'll do now is we'll place the chip back into, or the motherboard back into its casing, and we'll boot the console, and we should get Zell relatively quickly. So let me do that here real quick. Place this back in. Pay attention to your little sound cable there. We'll put a ring of light board in the front here, turn it this way, plug in some power, chip lights up, plug in some HDMI, and what we should get here when I use my trusty little remote to turn this on we should see the glitch pulsing, and then we should see a successful boot here pretty quick, which we do. And you can see up on screen we've got Zell. And that's the hard part, ladies and gentlemen. From there, all we're going to do is get that CPU key, plug it into JRunner, create the XE build, and then use that same Nandex to write it back to the console. But by the virtue of the fact that we have Zell, we now know that we have a successful RGH. Thanks for watching.